Hello, I'm going to do problem number 17 from the physics book. And problem number 17 reads, the distance between two telephone poles is 50 meters. When a 1 kilogram bird lands on the telephone wire midway between the poles, the wire sags 0.2 meters. Draw a free body diagram of the bird. How much tension does the bird produce in the wire? Ignore the weight of the wire. Okay, so first let's draw a diagram of what is going on. So there's going to be this one pole right here, and then another pole right here, and it's going to be separated by 50 meters. So right here, this area, this length is 50 meters, okay? And then there's going to be a wire in between, and there's going to be a bird sitting on it, so it's right there. And that's going to be the little bird, that little circle. So we see that the wire sags a little bit. So, and it's going to be sagging by 0.2 meters, big point, 0.2 meters, and the length of over here is 25 meters, the horizontal length. Don't be confused by this hypotenuse length because it's the length between the poles, not the length of the wire. And the bird is straight in the middle, so we know that this length right here is equal to this length right here. Okay, so let's draw the bird, which is going to be another blob again. So here's the bird. And, okay, so right there, it's going to have a vector downwards for its weight, which is mass times gravity. And then we're going to have tension 1 and tension 2, which are equal. So there's tension 1, and there's tension 2. And these two tensions are equal because the bird is placed right in the middle. So we can see that it sags on by 0.2 meters on both sides, and it's horizontally 25 meters in both directions. So the tensions of these two halves of the rope are going to be equal. Okay, so then we can draw the x and y components of the tensions. This is T1 sine theta, and this is T1 cosine theta. And then we can show that T1 is equal to T2 because of our observation that the bird is in the middle of the two. So, and then we're going to show that this is the positive x direction. This is going to be the positive y. Positive y. Okay. So let's add up our forces in the y direction, and then we can figure out what the tension equals. So the sum of all forces in the y direction is equal to, we're going to get T1 sine theta plus T2 sine theta, but T1 sine theta, and we know that T1 sine theta and T2 sine theta are the same because the angles are going to be the same here because the lengths of each of the parts of the triangle are the same. It's T2 sine theta minus mg, which is equal to mass times acceleration, but we know that the bird is at rest, that blob, so we can just make that go to 0. So since we know that T1 sine theta is equal to T2 sine theta, we can just say 2 times T1 sine theta is equal to mg, because we bring that mg over. And we know that it weighs 1 kilogram, and so gravity is 9.8 meters per second, but let's just isolate that T1 first. Equal to mg divided by 2 sine theta. Okay, so now we have to figure out what theta is and sine theta, but we already know that T1 sine theta is equal to 0.2. So here, let's just draw another triangle, nice and large. So what I'm drawing right here, I'm just drawing it larger over here. So you know that it sags by 0.20 meters. Draw that dot bigger. And then this is 25 meters, which means that, and then here's theta in the middle. If we calculate it, the hypotenuse is 25.0007 meters. But in order to find the angle, we can just ignore that. So we would say tangent theta is equal to opposite over hypotenuse, so it's 0.2 divided by 25, and the meters cancel out. So theta is equal to the inverse tangent of that. So theta is equal to 0.458 degrees. And we can just figure out what sine theta is over here because it'll make it easier for our work. So sine of 0.458 degrees is equal to, sine theta is equal to 0.00799. So over here, we know that it's 1 kilogram times 9.8 meters per second squared divided by 2 times 0.00799. And kilograms times meters per second squared is equal to newtons. So we know if we just do our little division and multiplication, 9.8 divided by 2 divided by 0.00799, we get that tension 1 is equal to 613.27 newtons. Okay, I hope I was able to answer your questions, and I hope that my ugly bird did not distract you. Thank you, and let me know if you have any questions. And this was problem 17. Thank you.